Hello, good morning, good afternoon, welcome. I'm very pleased to be joined by Keith Wipke. Keith is the Fuel Cell and Hydrogen Technologies Program Manager at the NREL, which is obviously one of the leading research establishments in the US. So welcome, Keith. Thank you for joining me.
Yeah, thanks for having me.
Thanks. And you're going to be one of our speakers at the upcoming World Hydrogen North America event, which is fast approaching. I think it's 21st to 23rd of May in Houston again. We had a huge crowd last year, so I think it's booking ahead of last year. So we should be well over 1,000 people at that event. Obviously, lots of interest around hydrogen. The NREL has obviously worked right across the energy transition, helping break new technologies, helping I guess the innovation of new energy technologies and pushing them up the TRL ladders. So can you give us a little bit of insight into the work you're doing in your program, specifically on fuel cells and hydrogen technologies?
Yeah, so our program spans everything from hydrogen production through the connective tissue of infrastructure, storage, and transport, and then ultimately in end uses. Fuel cells, but also other industrial decarbonization activities. So really pretty comprehensive from point of production through end use.
Yeah. And in terms of sort of starting, I guess, with the production area, we've obviously got this huge boom of interest, specifically the green hydrogen, as it's called, in terms of electrolytic hydrogen and all of the various sort of platforms of electrolysis. And we've got obviously the well-established, I think, the alkaline, which has been around for over a century, and a lot of, I guess, innovation around some of the new forms. What are some of your thoughts around that whole sort of area of innovation, and what are some of the key metrics you're trying to work on?
Yeah, so our biggest kind of North Star target right now is the hydrogen shot goal to get the cost of hydrogen at point of production from today's $5 or $6 per kilogram down to $1 in 1 decade. So that's $1 per kilogram in 1 decade. So that's a pretty significant reduction in capital cost, like an 80% reduction in capital costs. We are also counting on the cost of electricity, clean electricity, to keep coming down as it has been. But that's really one of our big focus areas, is reducing the cost of produced hydrogen.
Yeah. And in terms of how you do that, I mean, there's obviously, breaking new technologies. Yeah, I guess it's looking at the bill of materials. You've got some sort of key costs in some of the metals that are used in some of the electrolysis platforms. Can you maybe sort of unpick how likely it is to come down the cost curve, and how you come down the cost curve?
Yeah, so I mean, we're working on everything from different materials or more efficient use of current materials. For example, precious metals like platinum and iridium, the membranes themselves, the porous transport layer. So how do we do that kind of very small scale science more effectively so that the fuel cell or the electrolyzers come down in cost, but they're also efficient and reliable, but all the way up to the full system size as well, where we look at the cost of the balance of plant, the pumps and the drying of the hydrogen, the power electronics to make the DC power going into the electrolyzer. It turns out is a significant cost, and if nothing else happens, that cost probably won't scale as quickly as the actual electrolyzer stack will. So we're working with partners in that area to try and drive down the cost of not just the materials, but the whole system when you get up to megawatt scale systems.
Yeah. And I guess as a caveat to that, in terms of cost, is also around, I guess, sort of durability and reliability, and I guess reducing the OPEX costs, as it were. Is that also sort of just part of the challenge, is to make these things work for the long term in terms of 20 years?
Yeah, for sure. I mean, if you can make something last longer and not have to replace it, after 10 years, but instead after 15 years, well, you've just, significantly reduced the cost because you get to amortize that capital cost over a longer period of time, as well as, like you mentioned, the operating costs, like not just of the stack, but the balance of plant. How do you make each of the parts of the system more efficient? So we're really taking a holistic view of it. and covering everything from single cell research all the way up to full megawatt plus scale systems. And we're doing a lot of that with the U.S. Department of Energy directly. But I'd say the industry is also a very important partner for us. It's about 20 to 25% of our research in hydrogen is funded by industry and other stakeholders. So everywhere from startups all the way to established companies that have been in the business for quite a while.
Yeah, yeah, and what I mean what is that ecosystem like? You're seeing a lot of innovation team, and you mentioned startups, and is that quite a fertile ground, as it were, with lots of people trying lots of different sort of pathways and solutions and technologies, and I guess IP essentially.
Yeah, I mean, there is a lot of innovation going on right now in
Mm,
hydrogen, and
yeah,
and even though they may have really good ideas, they may not have an established way to reliably, repeatably compare, sample A versus sample B, which is what we've been doing for our research for Department of Energy for a long time. So we kind of bring that baseline understanding of performance and how to run the tests and not introduce noise into the systems. And we did the same thing in hydrogen storage over about a decade ago, when everybody was coming up with crazy ways to store hydrogen. And it turned out the way they were doing their tests introduced a lot of error, and they were thinking they were sampling things in one way, but they were calculating the volume fraction the right way. And so we, as a national laboratory, we kind of bring that diligence and methodical, repeatable process to our research that I think is a great benefit to established companies, but also startups that are again, innovating like crazy, but don't necessarily have the time to develop some of the techniques in the way that we have.
Yeah. You mentioned storage and I guess beyond production, it's a key part of the chain or the value chain, and as well as other infrastructure. What are some of the work out of the production area that you're working on?
Outside of production?
Yeah.
Yeah, so we are still innovating in hydrogen storage. It had been focused around onboard hydrogen storage for cars.
Mm-hmm.
It is now, I'd say, broadened into hydrogen storage in the form of carriers, like liquid carriers that you can make hydrogen, then convert it to something else, move it, and then convert it back into hydrogen. Simple
Yeah.
example is ammonia that everybody understands, NH3. But many new carriers being developed. So that's an area of research. Also, kind of bulk storage. How do you store hydrogen at a particular location cheaper at a large scale? Right now, we're using compressed gas tanks, typically in steel cylinders, is the main way, but that's good for, a few thousand kilograms. If you want to go to hundreds of thousands of kilograms, we're looking at underground storage, but doing that in a bulk way, where you're not necessarily having to depend on a salt formation or other geology beneath the surface.
Okay. So how do you do that if you don't have those sort of geological structures?
Yeah, so we're calling it engineered storage.
Uh-huh.
So this is something that kind of takes off from what the oil and gas industry has done for years, drilling holes, basically lining them in a certain way.
Mm-hmm.
And we're in the process of looking at a bunch of different technologies with, again, a lot of innovation from the industry on how deep, how wide a diameter, how many of them, how do you manifold them together, what are the materials compatibility issues. So again, this is not a tried and true thing right now.
Mm-hmm.
This is an active research area that we're actively looking for partners in that area.
Yeah, excellent. And in terms of I guess further down the chain in terms of storage, but also then I guess point of use, you're working around some of the HRSs and some of those other areas in terms of using the hydrogen.
Yeah, so NREL has been involved in hydrogen fueling infrastructure for over a decade. We helped California launch its market in terms of accurate metering of the hydrogen at the dispensers, safety protocols, validation of new stations when they came online. So now we're focusing our attention on heavy duty hydrogen truck fueling.
Uh,
And so just for a point of reference, fueling a car is about 1 or 2 kilograms per minute of hydrogen. Fueling a truck is more like 10 to 20 kilograms a minute. So an order of magnitude faster. So pipes need to be larger diameter. You still have right now a pre-cooling requirement down to -40°C. So good engineering challenges there, but also opportunities to innovate on the protocols of how to do it while still safely, also saving energy and doing it more efficiently, maybe not going down as cold, or using different materials on the tanks that can go and get warmer. So a lot of innovation happening there, but it's coming fast. I mean, these trucks are being developed and companies want to start getting to zero emissions over the road for transporting their goods. Amazon and other companies that move a lot of goods are saying, give us a zero emission vehicle option that gives us fast fueling and long range. And you can do some of that with batteries, but there are routes and duty cycles that are probably more suitable for something like hydrogen.
Yeah. Excellent. Fascinating stuff. Lots of work to be doing. So yeah, well, thank you for sharing your thoughts. And well done on all the work that NREL is doing, and we're both, as you mentioned, the DOE and also a large part of the industry. So great to chat to you, Keith. We look forward to your input at the World Hydrogen North America event. As I mentioned, it's 21st, 23rd of May in Houston.
Great. Thanks so much.
Cheers. Take care now. Bye bye.